Salam Sejahtera and welcome to my presentation. My name is Sheng. I am from Group 2. For my part, I'll present you the water reticulation design. My section is supervised under Dr. Elwan Hafizi Kasiman and Dr. Sainab Muhammad Yusof. What is water distribution system? Water distribution system is a part of water supply network with components that carry potable water from a centralized treatment plant or wells to consume to satisfy residential, commercial, industrial, and firefighting requirements. There are three types of pipeline in water distribution system: transmission pipeline, distribution pipeline, and reticulation pipeline. There are also three types of water distribution system, which are gravity, direct pump, gravity, and pump combined. After discussion, we chose gravity method to distribute the water needed for the project area. This is because no pump is required and low operation cost. The objective of conducting water reticulation design is to determine the capacity of storage water tank, determine the height of storage tank, determine the flow rates in pipe, satisfy minimum residual pressure head, and determine the pipe types and size. When these objectives are fulfilled, then the design is managed to supply potable water at sufficient quantity and pressure. When we are doing the design work, there are two types of pipe network that we can choose: dead-end network or closed-loop pipe network. In our case, we chose to have closed-loop pipe network because when one of the pipe is broken, another pipeline are still managed to transport the water. House Zilla Construction was appointed to design water reticulation system at Mukim Tebrau, Johor Bahru, Johor Darul Takzim, which is an industrial area. The project site is approximately 3.569 hectares. To complete the design task, total there will be 8 procedures for water reticulation department to fulfill the task: draw layout of pipe flow for project area, numbering the node and pipeline, calculate water demand of average flow, calculate water demand of peak flow, calculate water demand of fire flow, perform balancing flow for peak flow rate in each node, perform Hardy cross computation by using ePanel software for peak flow, and perform water tank design for the system. Now, I'll explain in details of every procedure in water reticulation design. First step is draw the layout of pipe flow for the project area. So, how do we draw the pipeline layout? The layout was drawn by determining whether using a closed loop or a dead-end loop network. In our case, we are using closed loop network. Then, draw the pipeline using AutoCAD. After that, we check whether the pipeline could cover every building or not. Next, we remove the extra pipeline to save the cost without affect the efficiency. Lastly, add nodes to every intersection of pipeline. This figure shows the pipeline layout that drawn by our group. From this figure, we can see that there are 2 separate closed loops, while the reason why we're doing this will be explained later. Step 2 is numbering the nodes and pipeline. This figure shows the identity of each node. The total node in our project is 30. And this figure shows the identity of each pipe. The total pipeline used is 39. The reason why we need to give every node and pipeline an identity is to provide convenience for the contractor when they are conducting the construction of pipeline, and also provide convenience when doing the maintenance. It lets the engineer knows which pipeline is having its particular value and check whether the pipe will satisfy the requirement or not. Step 3 is calculate the average flow of water demand. This table is used to calculate the average flow of the project area. It is the tabulation of estimated water demand rate for planning of external water reticulation system. This table is extracted from SPAN guidelines. This slide shows how we calculate the average flow of water demand. First, we determine the area of each building by using the function in AutoCAD. Then, we make assumptions on asrama pekerja, PE, PPU, and industri perkhidmatan teras for their water demand with reasonable value. The assumption value for each building is stated at the below right corner of this slide. After that, we convert the area founded from AutoCAD into hectare. This is because the average daily water demand estimated from the table of previous slide is in unit hectare. Lastly, we calculate the water demand of each building by using table 1 in Excel sheet. These are the average water demand that we calculated for each type of building. This shows the total average flow needed for the project area in unit of liter per second and meter per cube per day. Step 4 is calculate the water demand of peak flow. When we are calculating the peak flow, there is a parameter that we have to follow. Span guidelines mention that urban and rural areas will have the peak factor of 2.5, while FELDA schemes is 3.0. Our industrial area is categorized as urban and rural areas, so the peak factor that we choose when we're doing the calculation is 2.5. The calculation of peak flow is not complicated as what we did in calculation of average flow. The peak flow is calculated by taking the average flow times 2.5. Then we will get the peak flow value. The peak flow in unit of meter cube per day is 2034.886. Peak flow is also named as domestic flow. It is used in the calculation of water distribution, which will be used in the analysis of e-panel. Step 5 is calculate the water demand of fire flow. Fire flow is the amount of water that should be available for providing fire protection at selected locations throughout a community. The fire flow value will be the same as our average flow. Step 6 is balancing flow for each node. So, how do we distribute the water demand to every node equally? We calculate it by categorizing every loop as one group and distribute the water demand of this group by looking at there are how many nodes surrounding it. For a clearer view, I manually draw the example on how to distribute it. For example, the group 8, there are 6 nodes around it. So I calculate the total water demand that needed by group 8. Then I divide 6 and distribute it into each node. This table shows the water demand in each node after balancing the flow. Step 7 is perform Hardy cross computations by using the e-panel software for peak flow. There are a few design criteria that we have to take note when we are doing this analysis. Our residual pressure of node should be between 7.5 meter to 30 meter. The maximum allowable velocity should be between 0.3 meter per second and 2 meter per second. The node static level should be buried 1.2 meter below the ground. The head losses of pipe should be less than 2 meter per kilometer. And lastly, the minimum diameter of pipe should be less than 100 mm. After we perform the analysis by using e-panel software, we face some major problem, and we have to find a solution to solve it. The main problem is our residual pressure of some nodes is too high in our first proposed idea. The first proposed idea is we only design a water tank at the northern zone of the project area. While this idea failed because the difference between the highest reduced level and the lowest reduced level is too huge. Then we propose another tank at the middle zone. And that water tank will supply water to the southern zone of our project area. The issue of high residual pressure solved after this. Next issue is the velocity and head loss of pipe is not in the requirement. The only way that we can do is adjust the pipe to achieve a balance between velocity and head loss. This is the result from e-panel analysis after we key in the water demand that needed for each node, elevation, and the total water demand that needed by this project area. The result in table form has been shown in the report, so in my presentation, to have a clearer image of our result, I show it in the figure form. The last step is perform water tank design for the system. The factors that need to consider when designing a water tank are the height of water tank, capacity of water tank, and supply pipe from water main. When calculating the height of water tank, the information that we have to know is pressure head, elevation of node 1, the length of pipe from water tank to the node 1, diameter of main pipe, and the total water demand needed. After we have those values, we can use the Hazen-Williams formula to calculate the elevation of the tank. Next, we have to calculate the capacity of water tank. The information needed are the total water demand needed for the project area. and assume the height and diameter of the water tank and calculate it. The water tank have to be larger than the water demand. It have to be more than 1/4 from the total water demand needed. Last step is calculate the supply pipe from water mean. We have to check whether the velocity in pipe is lesser than 2 meters per second. If larger, then it's required to redesign the pipe. Next, to check whether the system need pump on suction tank or not, we have to check the H1. The H1 have to be larger than 7.62 to prevent the use of pump and suction tank. The HA is a required data that need to obtain from local authority. In our case, we assume it as 25 meters. This is the figure that drawn by AutoCAD after calculated all the values. Our Norton area water tank is built at ground and its elevation is 70 meters. The tank does not need to be elevated because the residual pressure head for each node at that area is fulfill the requirement. We repeat the same step as what we did for tank 1 in tank 2. This figure shows the details of Norton area water tank. The tank is elevated 5 meters to reduce level of 45 meters. Here is the summary of our project. In our project, there are 30 nodes, 39 pipelines, 9 loops, and 182 units of building. The types of building in the project area are Industrial Ringan Berkembang, Industrial Ringan Cluster, Kolam Tadahan, Industrial Ringan Sesebuah, and Industrial Perkhidmatan Terrace. The peak flow rate for this project area is 2,734.89 meter cube, and 2 water tanks is designed for this project area. In conclude, in our project area, there are 2 closed loops. This is to prevent high residual pressure head in node. We are having 2 water tanks in our plan. The Norton water tank is having the volume of 1,570 meter cube, while Southern water tank having volume of 884 meter cube. Both water tanks are designed as cylindrical dimension. The diameter of our pipe is between 100 mm and 300 mm. Every pipeline is buried under the ground at least 1.2 meter. The milled steel pipe with coefficient of 120 is chosen. The objective of our project is achieved so that our design is able to provide potable water to this area. Thank you for watching my presentation and I hope you enjoy it.